Hi, I'm Kashish, and today I'm going to discuss Homework 6, Question 2 for EL6303 Fall 15 under Professor Elsa. Okay. So, the question is x and y are independent with exponential densities f of x is equal to e raised to minus x u of x and f of y e raised to minus y u of y. Find the joint density of z and omega, where z is equal to x plus y and omega is equal to x by y. So it's not a very difficult problem. These are all the givens, and this is your problem. So first we find x and y in terms of z and omega from the two equations which are given to us for z and omega. Z is equal to x plus y and omega is equal to x by y. Now we will find x and y in terms of z and omega. So once you solve these two, you're going to get x is equal to z omega upon 1 plus omega and y is equal to z upon 1 plus omega. Now we find the Jacobian. So the basic formula that we're trying to get to is f of z omega is equal to 1 upon mod of Jacobian x comma y f x y. So this is the formula that we're going to get, that we're trying to get to. That's why first we will find the Jacobian of xy. So Jacobian of xy is dz dx, dz dy, d omega dx, d omega dy. And once you solve these, so dz dx will be d by dx of z, which is x plus y. D omega dy will be d by dy of omega, which is x by y. So we basically get this. Now Jacobian is this into this minus this into this, which will give us minus x plus y divided by y square. But since this is a mod, we will simply write x plus y divided by y square mod. Now substituting the values, so obviously this is in terms of x and y, and our final result has to be in the terms of z and omega. So substituting the values for x as z omega upon 1 plus omega and y as z upon 1 plus omega, we divided by y square, we'll get Jacobian in terms of z and omega. So when we solve this simple equation, we get 1 plus omega whole square upon z. Now, like I said, this is the formula that we're trying to reach to. We know x and y are independent, that's what is given in the question. And since x and y are independent, we can simply write f of xy is equal to f of x into f of y. Now we will find f of x and f of y in terms of z and omega. We know the value of x in terms of z omega. We know the value of y in terms of z omega. All we do is that we insert it in the exponential function. And once we insert it in the exponential function, this is what we get. U of z omega 1 plus omega and u of z upon 1 plus omega will simply give you a result, once it's multiplied, will simply give you a result of u of z into u of omega. So f of z omega, z comma omega, 1 upon Jacobian of xy, f of x into f of y. We multiplied it again because they're independent. So Jacobian we know is 1 plus omega whole square divided by z, so z will go on top here. E raised to minus z omega divided by 1 plus omega into e raised to minus z divided by 1 plus omega into u of z into u of omega. Once you solve this entire bracket, so e raised to minus something into e raised to minus something is e raised to minus something plus something. So e raised to minus z omega upon 1 plus omega plus z upon 1 plus omega. And then when you solve this bracket, you will simply be left with this. F of z omega, z comma omega is z upon 1 plus omega whole square, e raised to minus z, u of omega. And that is joint density of z is equal to x plus y and omega is equal to x by y. Thank you.